Our next presenter is Uddin Solachuddin from JCET Stats ChipPAC Inc. He's a senior expert engineer in field application engineering, and he's focused on IC advanced packaging and test and strategic and tactical business development. Uddin, the floor is all yours.
Thank you, Ira. I will talk about this strategy for the 3D IC testing in the perspective of OSAT, who is the really the manufacturing player in this semiconductor whole process flow. And I'm glad to hear the previous speakers who already speak on the, I believe they're from the EDA and from some of the simulation software maker. Now it's my turn. In my previous one, the previous speaker right before me is also speaking on the capital equipment. So those are the our partners in the OSAT business. If someone is not familiar with what OSAT stands for, is the outsourced semiconductor of assembly and test. So basically, we are the manufacturing guy after the foundry. So where you bring your chip and die, and we'll do the whole process. So let me start with this first slide, where I'm showing the semiconductor technology evolves. Is actually has been explained by the earlier speakers. Is all about technology node shrinking up to the 5 nano today, and we're dealing with this process capability also in the manufacturing process. So as an OSAT, even though my subject today for the presentation is more focused on the test strategy for the 3D IC, but we as the OSAT, we also offer the solution for the packaging and also the up to test and every aspect of the OSAT related, like the wafer level packaging up to the test system level tests and the drop ship of the products to the customer expected destination. And let me start with the market situation, that all these market drivers in this 3D IC segment, it all over from consumer, mobile and gaming device, high-end computing, servers, communication, automotive, military and aerospace, etc. Okay. With this type of illustration, basically, I'm trying to show that who are involved in this 3D IC making, not only the test, but also even the our customers, either fabless, IDM or OEM, they have all the choices. They have the options where they want to go in the packaging level, or they want to go to the monolithic 3D structure, or they might work together with the wafer foundry in this case. But of course, the design company, in this case, the EDA platform provider, the EDA company, the IP company, got involved also in this case. So for OSAT, we offer, like what previous speaker mentioned, that this kind of heterogeneous packaging falls into so many flavors, so many options in the business, that between OSATs, there's a very high competition in the technology offering, from the multi-chip module with the laminate, or either with the substrate, interposer, or even with the fan-out solution. And some, they call it as the system in packaging also, as a general offering for for this kind of, even though including the 2.5x D or 3D itself with the stacking or the inclusion of these between microprocessor and the HBM, those are the normal portfolio offered by OSAT. Then I'm coming up with this small illustration of what is the ecosystem in this industry for the manufacturing of these 3D chips or the 3D packaging. So if you look at this process flow, is the entire process flow of the manufacturing from the, that includes the chip design and also the wafer fab. Let me turn my laser pointer. Okay. So with this process flow is showing what are the roles of each of these players, where I'm showing this with this ball bullet, where IDM dominates most of the capability in this process flow, while OEM, fabless, especially IP company design house has no interest in doing the manufacturing, but the device owner, the IP owner, they really have the intention on how to participate in this whole process flow. So let me go to this, the bottom one between the foundry and the OSAT. As you can notice there are some of the overlap in the interest of doing the wafer level packaging and also the wafer probe solution, while the rest is dominated by OSAT. So you can see here that most of the manufacturing back-end process is done in the OSAT. And then when it's narrowed down to the specific process of this for tests, we as a OSAT, we really have the obvious role here, where I would like to highlight the differentiation of the OSAT role. So as I mentioned, I'm speaking on the perspective of the OSAT. OSAT, don't be surprised when you come to an OSAT and then talk to the guy or the similar role like me, the FAE or the sales guy, but the sales guy will bring the FAE or the TPM. And then we're discussing our technology. If you really need this kind of 3D testing strategy, the OSAT will offer you only in the ability that is covered by the OSAT. So OSAT will need your guideline. There will be a great information if you can provide this kind of test plan, where test plan, some people might not be familiar what is a test plan. It's basically a documentation showing the test methodology, showing the whole test algorithm step by step, from OS tests, DC parameter tests, AC parametric tests, functional tests, where all these functional tests is normally going to dominate the test time of, or the portion of the test program itself. So with that kind of guideline for the OSAT guide to help you or collaborate in developing the solution for 3D testing, then you will achieve the goal of doing this 3D tests in the OSAT level. So I'm showing here that collaboration with between the device owner with the EDA company especially, or collaboration with the some of the IP company also, in order for you to embed the DFT and any standardization of all these IJTAG, JTAG, and all these some other standards of the IEEE that I will mention later on, is all actually already developed within the capability of most of the EDA company. And then as a chip designer, your chip guy, your design guy needs to co-work with the DFT engineer in order to embed all this solution so that you can bring all this capability for OSAT test engineer, test development engineer to be able to transport or convert those information into the right selection of the tester or the ADE platform based on the application, based on what you're demanding in any critical of the parameters of the device itself. So we go to the next slide. So in a general perspective, most OSAT will offer this kind of service in terms of the packaging and also test as a turnkey offering or solution. They will offer the packaging and also test, but in this illustration, I'm specific more on the test. So as mentioned earlier, this test plan definition with the test development group or engineers to define the test hardware design, the test program development. Those are the very important things to do right from the beginning. Okay. We as an OSAT will also offering this kind of service on the design validation, test validation, the first silicon debug, the guard banding. When I call it as a guard banding means is related to the test limit, the prototype test, also the product test characterization, and then time to market is always our goals and objective to meet the customer's expectation in this case. And then furthermore, some of the services offered in the OSAT is this kind of test time optimization, the multi-sites development, or maybe if you brought it from the older platform, then if you want to move to the platform, another platform which is more capable or which is more faster or it has more features or instruments that is capable to meet your test demand, then these are normally the services or solution offered by OSAT. Then, as I mentioned earlier, this represents the entire process flow of the transferring the your device into the manufacturing stage as to us like we're the OSAT. So your new product or NPI, new product introduction, you would go through this definition of the test plan, the selecting the target tester, the handler of the prober that you need to use if you want to do wafer probe and also the final test as a turnkey solution on your device test, and selecting the configuration, selecting the right prober or handler interface and docking, and defining the process flow. And also probably OSAT will request you to come up with the statement of work. So that's a kind of mutual agreement between the OSAT guy and the customers to work together on what to achieve, what to hit on the objective for tests. Then from there, as a collaboration between the customer and OSAT, we'll go through this test development that includes all this understanding of the whatever you have put on your test plan, that includes this DFT strategy, and also any if you already converted the test program, test vectors or test pattern, that will be a great help to the OSAT. But some OSAT would offer, like us, also would offer the test pattern, test vector capture also. And then from there, the test engineer will do the coding, we do the all the programming aligned with the hardware or load board or test jig development accordingly. So that's normally a parallel work or process between the hardware development and the software development in this case. And then upon the completion of the development, then there will be some engineering stage here. I call that as the evaluation, where we'll use our correlation. I mean, we'll make some golden unit or correlation set. We do the characterization. We decide on the test limit or guard banding and anything related to this NPI stage. And then furthermore, if the customer really, especially on the automotive, that will be more thorough in the process of making sure it's a safe launch, that all the data is collected to the expectation of the product engineer or design engineer, and then we'll come to some pre-production up to the production release. And here's the real physical things that you would see if you visit the OSAT manufacturing test floor, that this fundamental requirement is all there in the OSAT, that you will see the tester. And what is test in the OSAT perspective is very simple, that you provide a stimulus to the device, and you measure or you gauge the output, the response of the device. And from there, you define the test program list with all the definition of the binning and what kind of physical bin out also you're expecting the OSAT to segregate the units, or if it's on the wafer sort or wafer probe level, then you're going to deal with the wafer map and all these hardware from final test to wafer probe. There's all the things that you will deal with the OSAT to develop, to co-develop and fabricate up to the release of those hardware with those redundant backup, etc. And in the business model of OSAT, basically test service is in terms of cost, is all about the test time. So that's one of the offering of OSAT that normally offers to the customer is yield improvement, test time improvement. Those are the economic factors that customers will look forward to co-work with the OSAT guys and engineers, or product test and product engineers in the manufacturing test floor. So, other than that, you will absolutely data is all you need in this case, that OSAT needs to provide all your data from the either the text base or with this standard STDF data log. We port it into the FTP port that we dedicate for you, we set up for you, so that your guys can, your engineers can collect the data from our FTP. And then from there, you would require some other data variants, like when you want an engineer to do some of the specific data log, some graph. In the old days, I call that a kind of a smooth plotting, or doing some of characterization based on certain tests. Then all this data communication will be provided by the OSAT to your server, in this case. So the high level of the 3D IC testing concept, where it's mentioned earlier that EDA platform is a key thing for the chip designer. So I'll list some of the tooling there, but you don't need to worry. Once you come to the EDA guy, that they will help you build your knowledge on how to embed the DFT strategy into your chips. Based on that, you will be you'll find the ease in developing or defining the test plan for the OSAT guy to follow. And then with the OSAT guy, you will talk about the selection. What is the ATE availability or handler availability, some of the associated equipment with the ATE. And you will request the OSAT to do the test development, or if you have the resources to do the test development, then that's fine. Or you're going to work together with the test house to do the test development. But it's all really a collaboration in the ecosystem. And then the goals here that customer would look at is from the, as mentioned earlier, the key things in this 3D IC testing, in order to enable all access to the I/O of the every IP block in your design, or between dies or die to die connectivity, or interconnection between those IP block. You have all this standardization of the DFT strategy, but again, EDA player or the EDA maker is having all the solutions. I can assure that is all available in the market now. So there's the chip design that you have to tag along with this DFT strategy. And then you may consider also this known good die program with collaboration with the OSAT also. So OSAT, and it's various, because based on my experiences dealing with this kind of strategy, customer may need to include the KGD program even up to the wafer level tests in this case, or the RMA test on a prober, a film frame prober. That's one of a good example where customer will use the RMA testing in order to make sure the delivery of the only good die or good unit in this case. And selection of the good known material also, that would be great, where if you want to do this known good substrate, known good interposer, and any other components that you want to put in your heterogeneous packages, then that would be a great option also in this case. And we as an OSAT, we also partnership with our substrate supplier, where the some customer for automotive, for example, they require the to make sure the automotive compliance, they do this kind of full wire or Kelvin test concept on the substrate supplier itself, that they will send us only the known good substrate to the manufacturing of the assembly at OSAT. And here's the last quadrant here, that you may end up choosing the final test or both with the system level test, where again, it's all depending on your test plan, your test characterization outcome, and so forth. Here's one of the traditional strategy in the DFT, where people talk about the scan test, which is basically you alter the flip-flop in your I/O of your chip, of your digital IP block with this scan test. But basically, scan test is part of the JTAG also. Okay, I'm not going to discuss very deep, because I believe most of the EDA guy has discussed this in their offering of their products, especially on their platform. They go very detailed, so customers can always consult better in more perspective with the EDA players in this case. See this standardization from the IEEE on the JTAG 1149, and also the this internal JTAG, where the IEEE 1687. This is an enhancement in the inter IP block ability to with those tabs offered in this standardization, is you guys in the design have more access to the inter IP block compared to the conventional JTAG, where that was meant on the more on the board level type of port access or IO access in this case. And also the IEEE 1500, where embedded core test, that's also offering the wrapper, WDR reflectors. Everything is about wrapper. Is a more sophisticated and enhanced features in the solution for this DFT strategy. This is another standardization that just came out most recently, the IEEE 1838, where it offers the stack level test success architecture. Those with the tool offered by them, especially the SEM, is a serial mode, serial control mechanism. That you will have the capability to do this, or you have the option on the FPP with the flexible parallel port, and also with the feature of the 3D IC stack integrator. And you don't need to worry, because all the standardization had been translated and into the features all offered by the EDA players in this case. And as a result, for those, you will have these boundary scan registers with this kind of capability. You will, for the boundary scan description language, this is one of the basic from the started from the JTAG 1990. That features in the JTAG is really the features that during the 1990s, when I was still a test engineer, test development engineer, this been introduced already, that customers came to us with all the test vectors and all these guidelines on how to respond into these functional tests with regards to this DFT. So this is really a good tools offered in the market already. And this is one of the advanced offering the IJTAG, where you have this option for doing this instrument connectivity with their offered language called the ICL, and also the procedural description language with the PDL. These are the more enhanced or advanced options or features in the EDA platform. So here's the almost the output that OSAT will need. So with your selected ATPG, where this basically the tools that you will use to produce the test vectors, the test pattern that you will work with the OSAT guy, test development engineer, on how to define your test plan, test list, etc. Okay, so when you come to the OSAT, you will see what is the OSAT test roadmap, and they'll show you that all the platforms that OSAT has is like us. We offer all the equipments or the ATE from most of the major makers of the ATE, and that will be applicable to whatever application that you're dealing with. So you have a rich options there, and don't quote me in this case that even though I'm classifying for a certain application in this case, that there's a great freedom for users. But again, that depends on what is the available capacity of the OSAT for a certain equipment that if you love to certain platform. So again, this is one of the challenge for customers when they come to the OSAT, that capital expenditure for certain equipment that demanded by the customer, which is unfortunately not available because of the capacity, or because maybe that's really a completely a new instrument, new capability, then that will be part of the discussion between the customer and the OSAT in this case. So and even if you discuss with the test engineer or the test development engineer, basically there are a lot of technique and methodology. Even though we're dealing with the 3D, it doesn't have that you have to port it on the very expensive platforms, because the more sophisticated or the more enhanced features in the ATE, then of course you will be facing with the cost challenges in this case. So again, is all the is a trade-off. When you pick the fancy one, then you will have to pay more expensive also in this case. But again, what I'm trying to deliver, tester capability since the old day up to today, if you know how to play or how to choose the right instrument, the right resources, there are a lot of techniques in how to do the right test methodology in the test development, in order for us to be able to use an older platform, for example. So choosing platform, it doesn't have to be the most fanciest one. Let's say if you are dealing with the high-speed tester, you always have an option of the doing the loop back and other technique in this industry. Okay. And then when it comes to the handling of the parts, you will deal with the prober and handler selection also. So in the market, you would see this various type of handler, pick and place. The gravity is very old one, or the rotary for the smaller package, and also the system level test, which is basically a handler with all these tests, the bench test capability in order to execute the application based type of testing. Okay. And when it comes to the prober, you will deal with the various prober capability also, where if you want to try TAM, or if you want just a room TAM, or if your setup, your load board and your device is very sensitive to the length in the wire, then you prefer to pick to choose the pogo tower. I mean the direct dock rather than the pogo tower. So there's also some options offered in the ETA maker that the prober maker that they offer the solution, or probably the third party for best direct dock and between the prober to the test head. And if you are, I mean, if your device is very sensitive to temperature, you might want to implement this advanced thermal control. So these are the critical parameters that whoever in charge in the product guy, or the some OEM or some IDM and even fabless, they have their own test engineer who can collaborate and together with the OSAT test development engineer to define and to select the right equipment in this case. And also this will be associated with the strategy of multi-sites, multi-DOT, and so forth. Okay, here's the strategy high-level illustration, where I already mentioned there from the design. So choose your right strategy based on the available standardization in the DFT, and your DFT engineer should know the answer in this case. And then come to the OSAT, defining the strategy with the OSAT test engineer or test development engineer, or with the field application engineer, in choosing your hardware, choosing your ATE platform, choosing your handler and prober, etc. Okay, but bottom line, you're always trying to get the best yield, PPM, zero field failure, especially for the automotive requirement. And then cost and quality mindset is the basic of this strategy. Okay, I'm already on the last slide of my presentation. So 3D IC is a new format, is considered a new format, even though it's been a decade right now, but that will continue to scale up. And DFT strategy is really, I call that, I use this terminology, do it right the first time, or DERF. So the designer or the chip designer needs to work with the DFT engineer, putting the right solution, right features in this DFT strategy from very early. And then with the OSAT partnership, you will choose all those that I've explained in my presentation, that selecting the tester, selecting the handler prober, designing the process flow together with the test engineer, manufacturing test engineering, how to deal with the rejects and how to deal with the RMA and so forth. Those are the critical part of making decision in this strategy. And this is not one role or one person type of responsibility, but this is a real cross-functional engineering program that involves multiple roles. As I mentioned, design, DFT, packaging, test development, the product tests, and also the supply chain management. And the last is really this community for collaboration, co-opetition between the OSAT or co-opetition between the EDA makers is really required in this ecosystem. So I think that's it from me, Ira.
Thank you, Uddin. Let's see, we have a bunch of questions here. So the first one really relates to, and we're seeing in heterogeneous integration, you know, what's going to happen when you get like photonic chips and RF chips on the same substrate with digital parts, and you know, what's going to be the hardest part of testing something like that?
Yeah. So more challenges is actually on the assembly side, but challenges at test, if there's really a bare die that to deal with, that's one of the obvious, because the top profile of the packages itself for the 2.5D, for example, if that's exposed, the challenges is more on the socket solution, but not the socket itself, but it's more on the handler part. Is called the work press or the nest blade. That's actually a solution between the handler or the socket guy that we need to co-work together with OSAT in offering the solution. So at my business, we offer that solution because we work a lot with our vendors in providing this they call it some of the selective soft nest blade or work press for us to be able to deal with this kind of critical or high risk top profile of the package itself. And when it comes to the test program itself, again, it's all in the eyes of a test engineer and test development engineer. You provide customer provide the right test plan with all the right test coverage, then that will solve the problem, because test engineer is just to transfer those information into the test code. That's my short answer.
Got it. Okay. And then, but related to that though, does your team work with the chip designers, or is let's say your customer responsible for working with the chip designer to make sure all the hooks are in the chips to enable testing? So what we used to call DFT, DFM. I mean, does your team get involved in that, or is that expectation is that the customer's already done that?
So honest answer is we really collaborate. I mean, we expect the customer to come with the instant solution already on this DFT strategy. So I believe you will never hear any DFT role in the OSAT, but more on the customer side, these fabless or the IDM. So in this case, the communication between the best, most efficient communication when the customer brings this complete, full covered objective of their test expectation into this format of called SOW, statement of work, or this test plan that details all this test methodology. Okay, but OSAT is always, I mean, like us, we were offering to write down together this test plan, sit down together in sitting down together either with the product engineer. Normally, a design engineer will not deal with the OSAT, but the product engineer or test engineer from the customer side will approach the OSAT test development engineer in defining this test plan.
Good. And in terms of heterogeneous integration and this advanced packaging, are test times increasing? And if so, is this due to the complexity or what's driving that, if that is the case?
Yes, without the this DFT strategy, test time will be a very great challenge for the customer. OSAT will love the long test time for sure, but then customer would expect the more cost efficient in the test time. So with this DFT, I heard that can cut the cost up to, improve the test time up to 3x in this case. So that means they can cut the test time up to 1/3. So
got it. And related to this, are you seeing a greater number of test insertions? Are you doing partial assembly testing, for example?
yes. So our offering is always we have preference to serve the customer in a full turnkey if it's possible. But then again, customer may have some different strategy of their geography choice also, where the end customer may be different from the location of our factory. So it all depends on the customer's call, but we try to always offer the full turnkey. So that means from the 3D chips, 3D packaging offering or solution that we have in our portfolio, starting from the fan out, from the 2.5D and 3D stacking. Also, we offer that, and we offer also the package design, the thermal simulation, and any other simulation we always offer. And then when it comes to the test, we also offer these test development service, and even on the characterization and so forth. So those are our preferred full turnkey services that we offer to the customer.
Okay. And one last question. You talked about it in terms of the equipment, but temperature testing, are you seeing more test temperatures with heterogeneous integrated devices, or is it more based on the end market as to how many different temperatures things get tested?
Correct. Yeah, based on the application, especially automotive will be requiring the tri-temp in this case, but for consumers, the worst one is probably hot temp. So in this case, 3D IC as the application served in the package, that will decide on what temperature is gonna be needed. But we do various requests in this case that most of the requests is up to the hot temp, but tri-temp, especially for the automotive, is also, the demand is very increasing in this case.
Great. Well, great. Thank you, Uddin.
Thank you, Ira.
Then once again, I would like to thank our lead sponsor, Advantest, rated as the #1 supplier of semiconductor equipment in 2022. And our other sponsors, Amcor and Cadence, their sponsorship has made this event possible and free of charge. So when you have an opportunity, please thank them. And I thank all of you for joining us today. And we look forward to seeing you tomorrow. Have a good rest of your day.